I actually did my undergraduate degree in cellular biology here at UGA, where I started doing undergraduate research with Dr. Ping Shen, and he's actually who introduced me to the neuroscience program. His lab, our lab, specializes in the neurobiology of fruit fly food intake. So that might seem a little off the wall, or why is this relevant? But fruit flies are a fantastic model because they have a very simple nervous system, but they do all the same kind of complex behaviors that we do. They eat food, they make complex choices, they execute complex behavioral paradigms, but they do so with a numerically simple nervous system. So while we have millions of neurons and billions of synapses, they do the same kinds of things with roughly 10,000 neurons. What we found in that was actually a novel receptor that regulates food intake. Specifically, if you reduce the activity of this receptor, flies eat less. So we got a little bit of seed money and decided to do a shot in the dark and see if the same pathway was present in mammals. And it worked. So we actually did a drug screen and picked some candidate drugs and administered them to the brain of young male rats, and were able to block food intake. More importantly, we blocked the intake specifically of high-fat, high-carb food. If we can understand the basic neural pathways that say, eat as much of this delicious food as you can possibly get in your body, if we can figure out how those pathways work, perhaps we can block them in certain situations, or if we can figure out what pathways tell our body that we're hungry and to eat as much food as we possibly can as quickly as possible, then possibly we can suppress those pathways. When I was looking at prospective postdoc opportunities, I knew that I wanted to specialize in understanding complex behaviors, preferentially I was preferring to find something that was doing that in rodent models. So the lab at Johns Hopkins that I'll be joining is the lab of Dr. Michaela Gallagher. So it's not exactly Alzheimer's research. Alzheimer's is not well understood. It's partially a disease state, but it's best characterized by the residues that it leaves behind, right? The damage that it has on neural networks. However, there's lots of other different types of things that can cause similar damage, and we don't really know a lot about what's Alzheimer's specifically versus what's just normal aging. I published a manuscript in PNAS, and I was second author on that, and my baby, my favorite, was the publication that I had on my rodent work. So I was very pleased that study was a struggle from the start, because I had to really branch out of my comfort zone, learn an entirely new model organism, entirely new protocols, and it was really amazing to be given that level of control over my project, and also terrifying because got to figure out some way to make this work. The Neuroscience Journal Club started up probably, I think, my first year that I was in graduate school here, and it's been really great. It's a primary literature-based seminar course, and prior to us having that, we were kind of spread out around campus and didn't really get to talk much because we're so, our disciplines are so broad and we're in different buildings. So that's been a really wonderful weekly meeting where we can all kind of get together and show representative papers that we're excited about within our own disciplines, and everybody can kind of get out of their comfort zone and see what other people are doing. No, this thing, anybody that, comes into grad school feeling like they're lost and everybody knows what's going on is just, you're just wrong. Everybody gets into grad school at the same point. None of us know which way is up or what we're doing. It's hard to explain to anybody what you're getting into when you're getting into grad school, because you're committing to the next 5 years of your life, 5, 6, 7, 8, whatever, however long it takes, to complete some substantial body of work. Another difficult barrier with grad school is realizing that professors are people. And these are the people that are going to be your mentors and are going to be the ones that teach you how to think like a scientist and help you develop the networks that you need to develop and develop your career goals and things like that. Stick with it. It's worth it at the end, you know. It's a lot of work, and there are days when you are really sure that everything's just going to come crumbling down. But I'm so glad that I stuck with it, because the amount that I've grown as a person, grown as a professional, and grown as a scientist by getting through this process has been tremendous. Studying science gives you something that studying nothing else does. It gives you an ability to really question the world, and I think a lot of people lack that today, you know. It's tremendously empowering to feel like the world around you is not a static thing, and it's not, it's permeable. You can ask it questions and you can learn things from it. And getting through grad school, you know, pursuing a graduate education in science gives you the tools to do that, to really query the universe and figure out what it's all about.